So now, and the next thing is if the path doesn't exist, this loop will exist, and at the end we return a null because the path does not exist. Let's create this function called join path, or I'm going to call it like that, join paths. We have the separator, or I'm going to create a file for that because it's more simpler. Join paths, and here we include the header file, and we create a function. It will return a pointer to a string, join paths, the separator, and the second will be path1, and the other will be path2. Now you can type in the code here, a custom code based on the requirement, because there are certain functions we're not allowed to use. But either way, there is a function in the string library we can use, the strcat function. But let's do our own code here. Just not forget that we need to create this function called join path, and the other one to check if a file exists. So I'm going to add another file called file exists. So in the main header file, we update the header file, join paths, return a pointer to the array, a string, so path1, path2, and the next thing is, okay, we're going to combine these two paths. So the first thing is I'm going to declare a variable called I and another variable called length, the length of the returned strings, and the whole path will be stored in this variable called path or joins. Great. So while path I, we say I plus plus. So here we just looking for the length. So well, it's different than the null character. We say we loop till we find the null character. Then after that, we say the length. We add the length for the path one. And next, we reset the I to 0. Then we add also the length for path 2. So I path plus plus different than null. And at the end, we add the I. So this is the length of the path 1 plus the length of the path 2. And we have to add another space for the separator, the character here. So I'm going to say the length will be plus 1 again. So this will add up a space for the separator. Now in the join path, we call the malloc function, and for the malloc function to be called, we need to include the std library. Okay, so size of join times the length of the pair plus 1, because we want to add up plus 1 since we have to end the pair with the null character. Here we need to add a check if the malloc function succeeded. In order to to get things very simple, we're not going to check for that for now. And next we have to copy the paths in the newly allocated memory. We're going to copy the characters inside these new strings. We start for path 1. So for I is equal to 0. And I'm going to declare another variable called k. So the k variable will be used to loop through the paths, and the I will be used to loop through the joined paths. So while paths 1k, we say join I is equal to path 1k. Then we increment I plus plus. Then we increment the k plus plus. And the next thing, we do the same for the path 2. We're copying the path 2 inside the joins. But before that, we have to first copy the separator in the join path. So it will separate path 1 and path 2. Now joined, the character will be the separator. So we add up the separator, and after that we can continue copying the path 2. So here we have to reset the k variable to 0, but the I is the index inside for the joint strings. So it changes to 2, and now we are good. At the end, we just add in the null character, and once we're done, we return the join. So this is it, how we join. We It's like concatenating these two pairs, but with a separator. So we're done with this first function. Now the next function is to check if the file exists. How do we check if the file exists? I'm going to first include the main header file, and the file exists will return an integer, and it receives the file name or the file path. Let's say the file path. How do we check if a file exists? First, we have to include the sys. There is a library we need to include, and the sys stat. We check the status of the file. I'm going to type in the code and explain. So, struct stat buffer. I don't remember exactly this the type's name, but it should be correct. So there is a function we need to call. So if stat, then what we pass in is the file name, and then we pass in the buffer. If this is equal to 0, that means the file exists. Oh, forgot I have to say file path. That means the file exists. So we return a 1. But if the file doesn't exist, we're going to return a 0. So this is how we check whether a file exists or not, knowing the path. So this will check for the status, for example, the permissions, all those things. We don't need to know those things, but I think if it returns a 0, it means that it exists. But if it returns another value different than 0, that should be an error, so the file doesn't exist. Let's add this prototype to our main.h file. Now I think the puzzle is complete. There is another things I wanted to add is sometimes people might call this function with an always the absolute pair. For example, in the main file, if you type in the command, for example, the user might type in bin ls, and this is already the absolute path to the file. So inside the locate function, we're going to make sure that we're going to first make sure that the path, uh, the file exists first. If it doesn't exist, then we can search from the paths environment variable. So if file exists, we pass in the name. We don't need to look for the file name because it already exists. Then we return the name of the file. I'm going to move that a bit on the top. So this is a simple code. It's not perfect, but basically this is the main idea behind how to locate. We first check if the file exists. If it doesn't exist, we start to look for the path from the end variables, and then we loop through, we combine, we join the file name with the directory names, and we check if the file path exists. If it doesn't exist, we just have to return a null. Now let's go back in the printf the main function and try to see if this works. GCC, the start sign, the output file name. Oh yes, we have a problem, but argument is of type constant char. So inside the main header file, let's add this thing constant. We're not changing the name of the content of these parameters, so we're going to add const everywhere. Here also we're going to add in constant. The function does not change the values inside this variable. So let's go back in here to constant. And in the join path, we're also going to add constant. All the parameters are constant because the functions does not have to modify them. Let's try again. And yes, here we have a problem. It says return discard constant qualifier from pointer target. Okay, this is good. There is something more to add to what we just did. And this is whenever you call these functions, instead of returning the actual value, they should return a copy of the value. So the caller, the function that called, um, uh, for example, the getM function, if it has to operate or modify the returned value, that will not affect the environment variables. So we're going to create a function called str_dup. This will just duplicate a string. It will create a copy of a string. So from each of these functions, we're only returning a copy instead of the original value. We don't want to modify the original value. I'm going to explain why. Str_dup. This will be a custom function. So inside the main file, we add the prototype of this function, str_dup constant char str, and the definition would be, we go here, str duplicate, and here we include the library, the std_lib library, because we're using the malloc function. I'm going to declare a variable called size t, and the type we set it to 0 first. We're going to find out what is the length of the string. So while stri plus plus, we look through, and the length will be equal to I. And next, what we're going to do will be to create another string, and the string will be called str. This will be the copy of these strings. So st_str malloc size of s underscore start_str times the length. So we add a +1 because we want to have enough space to store the null variable, the null character. And next, we're going to copy this str to the underscore str, then return the str, the underscore str. So the copying would be, we set the I to 0. So while I is lesser than length, we say underscore I, stri, and stri is equal. Then we increment the I. And at the end, we have to add the null character. So inside the loop, we can add the null character because by adding lesser or equal to length, so if I is equal to length, it will be the null character from the str that will be copied to the underscore str strings. Then we return the underscore str. So here we duplicated the str string. As we said, we're going to move from within each of these functions and call the top function. So um, we don't want to mess up with the environment variables and changing them from somewhere else in the code. So instead of returning the actual value, we just returning a duplicate. And inside the file exists, we don't have to return anything. For the join path, there is nothing to duplicate. But here for the locate path, we might need to duplicate. For example, here, instead of returning the names, but we're going to duplicate str dot. So it is the calling function that has to make sure to free up the spaces. What next? The next thing will be here. We call the str talk on the path. So this path has been returned from the getEnv, and the getEnv called the str_dop, which means that this space allocated from here also have to be free app, uh, freed app. Yes. Now we have str_talk. So what we have to do here instead, at the end, before returning what I'm going to call it, before returning the file path, we're just going to free the path that has been allocated from the getEnv. Then we return the file path. But anyway, we also have to free the path, and here before returning null. So we won't have any memory leakage. And here too, the join path return an allocated string. So if the file path doesn't exist, we have to free the file path and set it to null. So this is important. Even if the code works well, we have to track memory leakage and see which function return um, an allocated value. So if we don't need the allocated value anymore, we have to free the space and set the variable to null. So this is it, but here there is some enhancement we can add. We can just say we're going to break the loop. So we break the loop like that. So if the file exit, we break the loop. Then here we return file path. Anyways, if the dir path is null, it's going to return um, file path will be set is already set to null, then it will return a null. But if the file exit, this will break the loop. So the file path is not null, then this will return a non-null value. I think this is all for the locate function. Let's go back in the main function. So here we call the locate function. The locate function can return the absolute path or a null if the file name doesn't exist. So I'm going to create a variable called file path. and call the locate function. So it's going to locate the ls command. I'm going to call the printf function for the file path. But before, let's add an if statement if the file path is different than null. So that's it. Let's compile this code and see gcc main.c, and the output file, oh, sorry, the file, the output file name will be called program. Oh yes, the free function, we have to include the std lib library in our locate function file. So include std lib library file library. Now GCC we compile those files, and that's it. We have another problem, the get env expected constant, but argument is of type int. Oh yes, it's the same problem again. I don't know why I always type a character instead of a string. So we add in the double quotes. Let's compile the code again. The same thing again in the main header file. Yes, this is, I forgot to save the file. Great. So now we have the main function. The main function, we call the locate function on the ls. So it says, and here it is. This is the pair, the absolute pair displayed. So you can say else printer command not found. I'm going to type in command not found. So now we are able to locate a command from using our C program. So we have the locate function. The locate function search for the ls. But if we type in something like being ls, this is already the absolute path. The locate function, the first thing it's going to check is whether this path already exists. If it doesn't exist, then it's look for in the path environment variable. So let's compile this code again. And it says being ls. What if we type in something like x, y, z? Command not found. So the x, y, z command doesn't exist. So the locate function will return a null. Everything is working fine. Now the next step is to create a simple shell where the user can type in whatever command he wants. I'm going to clean up this code. So here we're going to include another library called the unit std library because we plan to use the executable function. So now we have this loop where the user is asked to enter a command. So char command is equal to null. Then the args array. For now, we're going to keep it simple. And the next step is we're going to print the prompt to the user. We tell the user enter command. Then what else? We call the getter function, but the get line function. But let's declare another variable. I'm going to call it buffer size type, buffer size, and another will be a size type and red equal to 0. Okay, so we call the get line function get line. We pass in the address of the command variable, then the buffer size, and from the we're reading from the stdin uh, file. What else? We have to replace the last character because the get line function also add up the line break character. We're going to replace it with a null character. The next step is to set the args array, the first argument. We're going to set it to the command. But before we execute the command, we have to first check if the command exists. If the command doesn't exist, then we have a problem. So the first thing I'm going to declare will be command, let's say file path or command path. Now we call the locate function. So command path is equal to locate command. So if the command exists, then this will be set to a non-null value. Then we say if command path exists. If the command path is not null, that means the locate function has been able to locate our command. So let's add it here, command path. Then we call the executable function. There is something I want to add, but you can look for the previous videos how to create an interactive shell. But anyway, you type in for. We don't want the shell to stop when it failed to execute. It succeeded to execute the command. So I'm going to create what I'm going to call it, a child process, and call the execv function from within this child process. Okay. Then after that, since we know that the command path exists, we're sure at 100% that this will succeed. The call to execv function will succeed, and the child process will be replaced. So if the command exists, we set the args arrays accordingly, then we create a child process from within which we call the execv function. So creating a child process will prevent the parent process being replaced. Only the child process will be replaced when the execv function succeeds. So the parent process can still continue asking the user to enter command. So here we call the wait function, but before that we need to include the sys wait library. Yes. So the parent process will wait for the command to execute, and after we can continue asking the user. Now else, that means the command doesn't exist. We have to print an error message to the standard error output. The formatted string will be we type in the command name, then we say command not found. And that's it. I think this is all for the simple shell. Now let's compile this code and see. No error. Okay. Yes. Now the program says enter command. Now I'm going to type in ls. And here it works. So ls, then after that the ls, it locates the command ls, then the command path is found. So we set the command to these things. And what else? We call the wait function. So here it is with the locate function, find the command path, the executable path. So it is the actual absolute path to the executable that is passed in here for the exec function call. Now let's type in the absolute path like that, being ls. It still works because the locate command check first if the bin ls file exists. If it does exist, it returns the same string. Now let's type in something else, xyz. It says xyz command not found because the locate function returned a null, and the null value uh, is not means that the path wasn't there in the environment variable. So we display str, we display command not found to the standard error output. This is all for this session. Now, I wanted to add some other things. I wanted to add some other things. And what are these? Let's say we call the wait function. So if the child process is done executing, we're going to free up the command path because it is an allocated memory, an allocated space. So we call the free function to free up the space. Then the command path, I'm going to set it to null, good practice. And that's it. Now we're done. We're going to compile this code again to make sure that everything works fine. Oh, in order to call the free function, I need to include the std library. Now let's run this program. Okay, you type in ls, it works. You type in bin ls, command not found. But if you type